So this is topic 5.7, solving exponential equations with no like basis. So before we solve equations with no like basis, we're going to review just really quickly how to solve equations with like basis. So remember, our bases are the same, so we just set the exponents the same. So that means x is 5. Okay? And then for the second one, my bases are 2 and 4. Those bases aren't the same, but I can rewrite 4 as 2 squared. And then I'm just going to rewrite the rest of the equation. So that's 2x plus 1 equals 2x. So I multiply 2 times 2x plus 1 is 4x plus 2 is equal to x. Subtract x from both sides. 3x plus 2 is equal to 0. Subtract 2 from both sides to get x by itself. 3x is equal to negative 2. Divide both sides by 3. And then x is negative 2/3. Okay? So in the second one, our bases were not the same, but we could make them the same by writing 4 to 2 squared, because those are equivalent. Okay? So now when we look at example 1, we have 4x to the 13th power. So we have 4 is our base, and 13 is our base. Well, I can't change 13 into 4 to some power. So I'm basically going to take the log of both sides. Okay? Since this is an exponent, I'm going to use the power property, which states that if it's an exponent, I can just put it in front. Oops, it's not an equal sign there, sorry. So it'd be x log of 4 equals log of 13. Now I'm just going to divide both sides by log 4 to get x by itself. And so my final answer is log of 13 divided by log of 4. And then we're just going to simply, I'm going to go to Desmos. And I'm going to type right here, log of 13 divided by log of 4. And that's about 1.85. So my answer for example 1 is 1.85. Okay. So for example 2, we have an exponential plus 4 is equal to 28. And then our base over here is 28. So we have to somehow get rid of this 4. So I just have 2 terms on both sides. So I'm going to subtract 4 from both sides. So 6 to the x power is equal to 24. So now that I have one term on each side, and I can't make the bases the same, I'm going to take the log of both sides. So I have the log of 6 to the x power times the log, or is equal to, sorry, the log of 24. So remember, this x is the exponent, so I have to use the power property so I can rewrite it so I can solve for x. So I have x log of 6 equals log of 24. I'm going to divide both sides by log of 6. And then I'm going to simply just do what I did last time and type it in. So I have the log of 24 divided by the log of 6. So now when I did the log of 24 divided by the log of 6, That's 1.77. So my final answer is x is equal to 1.77. Okay? So now we're going to look at wonder if there is an e. Okay? So we do it the similar way. So if there's an e, one base is e, one base is 6. There's no way I can make those the same bases. So I'm going to take the natural log because e and natural log are inverses of each other. So I'm going to take the natural log of both sides. And the reason why I'm using the natural log is because this problem involves an e. So ln and e. First I'm going to use the power property, which states that this is my exponent, so I can move it in the front. And then I have ln e equals ln 6. So ln and e, they're inverses, so they would cancel each other out. So I'm just left with 4 minus 3x is equal to ln 6. I'm going to solve for x, so I'm going to subtract 4 from both sides. So now I have negative 3x equals ln 6 minus 4. And this is an L and an N. Then I'm going to divide both sides by negative 3. And I'm going to get my calculator wherever I put it. Here it is right here. So I'm going to do ln 6 minus 4, divide that by negative 3, and my answer is 0.74, sorry. Should have said it correctly. 0.74. So I'm just going to round to the nearest hundredth, and that's fine. Okay? So now let's go ahead and look at the very last question. This one also has an e, and I cannot make these bases the same. So I'm going to take the ln of both sides. Oops, forgot to put the ln on this side. My bad. So we know that the power property states that I can move the exponent in the front. Okay, ln and e are inverses, so they will cancel each other out. Then I just simply solve for x. So I'm going to subtract 1 from both sides, so that's ln 51 minus 1. Divide both sides by 3, and then I'm just going to go back to my calculator, type it in. So ln 51 minus 1 divide by 3. 0.98. Okay. And that's basically it.